Alright, what I'm going to do here is I did jump this electrolytic right here. It had zero effect, so I doubt that that's a problem. So this feedback circuit here from this multi-vibrator, where you basically feed a plate to a grid, that generates an oscillator called a multi-vibrator. They're extremely unstable. They rely on this pulse from the sync separator here to time this thing. Basically what you do is you set it up, this oscillator, through a timing circuit, which is based on the bias of this tube through this grid, so that it runs a little bit slower than the vertical rate. The idea is it runs slower than the vertical rate, then every time it sees a sync pulse, it kicks off and starts to scan again. If it was running too fast, it would just roll. The sync pulse wouldn't do any good. That's why sometimes you'll notice if you turn a TV off channel, if you listen carefully, you'll hear the vertical oscillator, which typically runs about 60 hertz. You actually hear it slow down, and when you click onto a channel, you'll hear it speed up. That's it picking up the sync pulse, and so it'll sync up. Anyway, the guy in question just blew out of here. Okay, here we go. This one right here. Let's see if I can get a clearer picture of that. Come up very close. No, I'm sorry. I don't have a very good camera anyway. Right here. This capacitor right here, which is a 039, is a 10% rated. Well, that just means they don't want the thing to be having to adjust constantly for the vertical hold. But anyway, the 39 there on my set is a 200 volt, which seems kind of surprising considering the voltage spike that's coming out of this thing. If you take a look right here at the grid, you get a 100 volt or a 270. I'm not sure. I don't know if that has to do with when there's a signal or when there's not a signal. But anyway, that thing that's installed in the set is only a 200 volt cap, and it looks sweaty, for lack of a better term. Whenever you have a film cap that doesn't look nice and dry, it looks sweaty, to me that's not a good sign. And it's not because of cigarette juice it's accumulated on it, because all the caps around it look fine. So I'm suspect of this guy. So rather than just shotgunning every single cap, this one's pretty easy to get at, so my plan will be to unsolder it and remove it and test the set again and see if I can get that little bit of shakiness out of the vertical. If it doesn't, then I'll just move on down the line. This guy will be next. This right here, this cap, pretty sure that's a disc cap. I really doubt that's the problem. Another one that I probably want to look at would be this cap right here. It's a grid coupling cap. Any leakage there at all is a bad thing, because it just upsets the bias of the tube, and that's never good. So there's not that many to check. There's 056, the 033, 039, and this coupling cap from the sync separator is another 039. That's a 039. That's a 0039. That one's going to be done though first. That 0039 is the sweaty cap, and I suspect he's the culprit. I'm trying to illuminate the .0039 capacitor that I think is part of the problem with a little bit of jitteriness. If you see this yellow here, let's move this out of the way. There, I think that's a better view of it. There we go, that one right there. It's got kind of a waxy, slimy look on it that I'm not sure what's going on. The other ones around it don't have that same effect. It's only a 200 volt. I'm going to use some solder wick and remove that and check it out. Some other suspects will be that one right there, which is also part of the feedback, and I think that one right there will need to be looked at. I'm not sure what that big guy right there does, but pretty sure that 0033, that 0039, I'm not sure. I think that's that 0056. Actually, I think that's one I don't have, so I don't think I'll be able to replace it. I'll have to make an order to get that one. That's in the grid circuit of the multi-vibrator that comes from the plate to the grid of the output part. So that's also very critical to me. I don't want any leakage taking place there. I could just pull it out and test it, but I'm definitely going to get this guy first. I'm just going to do them one at a time and see how they affect that jitteriness I've been experiencing. I'm going to use some solder wick to remove the solder from the bottom of the PC board, and then extract it and check it and replace it. Okay, this is the PC board. The area I'm targeting is right here, and I'm going to be using my soldering iron, solder wick, to remove the excess solder and a little bit of flux. And what I do with this is a flux is I'll actually heat up a little bit, make sure it's all over this copper wick. That helps the solder to flow to the wick. And then the idea is you take the wick and you put it up against the solder you want removed, and then put the gun on the other side of the solder wick. You basically heat up the solder wick enough to where it can melt the solder. And I assume it's a capillary action that causes the solder to flow up into the wick. And then you remove it and you have no solder left, and then the part just basically falls right out. Now, you could probably just directly heat a part. This is not turned on right now anyway. Just heat it up and pull. You know, it would come right out. And what that would do would leave a little bit of solder there. It might fill in the hole as you extract it, may or may not. It'd be a little bit messy. I don't know. I just like to use solder wick, make everything nice and clean, and replace it with some fresh solder. Anyway, I'll get to that later. Okay, we're going to go ahead and be removing this capacitor I already previously identified. I'm going to be using the solder wick. Soldering iron is now hot enough, so first thing you do, make sure the soldering iron is nice and clean. I'm going to put a little bit of flux on this wick. The way I do that is just kind of stick the wick down into the flux and just do that, and it'll quickly heat up and pick up a little bit of the flux. There you go. Now that thing is nicely fluxed up. Now I'm going to go over here to where I had previously identified the offender, potential offender, and I'll just take the thing there, and that'll take up all the solder right there. I don't think I got it. I'll try it again. Usually you'll see the solder start to flow up on the thing. Do that again over here. The key here is to wait for the solder to flow onto the braid. There, I'll try that a little bit more. I got that. Looks pretty good. That's about ready to come loose. I'll try this one again. Get this braid straightened out. Here we go. So I'm going to get right up in there and try to get that hot enough to where it flows, and it flows into the braid. There, I can see the solder liquefying, flowing into the braid. That's good. This cap will probably just fall out when I'm done. Okay. Okay. Let's see how soft it's ready to pop out now. There it goes. There's one. There, it's out. I didn't get quite enough solder off of there. I'll get it a little more time with the wick. I wanted to get it nice and cleaned up. There we go, I think it's out. Oh. Solder really should flow into that wick. I might have too thick a piece of wick here. Let's see if I can pull that cap out. Okay, you can stop. So we got the cap out. It's right here. It's an 0039 at 200 volts. And I suspect that this is the problem. So what I'm going to do is get some of this stuff here. Alright. What we're going to do is we're going to hook it up to the cap tester. I don't want to bend the leads up and all that kind of stuff, so I'm just going to use these to give me a little more working space. And first we'll put a good cap in there just for the heck of it. This is also an 0039. This is the one I'm going to put back. Even this one tests good. I'm putting back this new one. Go through all this effort and just to put the old cap back in, especially if I think it's a critical circuit. 0039, so we look up here. It's in this range. Actually, either one of these ranges is good. I'll put it there. 0.001. 0.001 to 0.5, 0.1, 0.05. So I'm figuring it should be right around in this area. Okay, that's a good one. And you can look at the eye tube and see that it opens up fully. That's what you want it to do. Then we'll do a quick voltage test, make sure it doesn't leak. It'll snap closed for a second, then it should open wide open. There it goes. That's perfect. That's the good cap. Now we'll put in the bad, well, suspected cap, I should say. And the first thing I'm going to do, I'm not going to do a voltage test. That go back to the, see how this thing works. Ooh, that's interesting. Oh, wait a minute, here we go. Alright, well, it's testing fine. That's not good, because I was hoping it would be a little bit iffy. Let's check the leakage. It's only rated at 200 volts, so I'm going to go to 150 and see what it does. Uh-oh, this is not good for me. It's testing out perfect, so I have a feeling this is not the problem cap. Anyway, I've already pulled it out, and like I said, I'm going to go ahead and replace it with this one anyway, just because I've already gotten this far. And I guess I gotta look for another cap. Anyway, that's it for now. Thank you. The next capacitor that's suspect is this capacitor. That's, well, you can't really see it clearly, but you see that little green loop right there. It goes between the two terminals. I had to loosen the PC board up off and kind of pick it off to the side to get at it. But at least I don't have to pull it out completely. And I've identified the two leads that have to be unsoldered, so I'll be removing that. Hopefully that'll be it. That's another one that's right in that feedback loop. I think it was, for some reason, I'm trying to remember what the plate lead of this thing was. I can't remember if it was pin 5 or not. It might have been pin 5. That was the output from this that goes through this feedback loop. You see there's a 5 there. There's a capacitor, there's a resistor, and that goes to the capacitor I just did. So hopefully, like I said, this will be it. And I don't know, it's kind of a pain to get at. I wish I had this problem before when I had the PC board completely pulled out, but it just didn't start happening until after I had all reinstalled and watched it for a while. Then it started to occur. So I'm hoping it's nothing else but a capacitor going bad and not something that I had done and just didn't notice after the CRT replacement. Anyway, we'll see.